Complex numbers are numbers which are composed of a real value and an imaginary value. Imaginary numbers were devised to allow us to work with negatives under square roots. Among other things, imaginary numbers help us to describe the solutions of quadratic equations whose graphs, which are parabolas, do not cross the x-axis. The definition of an imaginary number, which we just call I, is it's the square root of -1. So the square root of -1 equals I, or the imaginary number. So to take the square root of a negative number, for example, square root of -5, just take the square root as you normally do, and then put an I at the end. So the square root of -25 would be 5I. If we need to square an imaginary number, it's the same thing as squaring the square root of -1. And since a square and a square root cancel, I squared is equal to -1. And that's going to come up several times in these types of problems. So let's start by simplifying some expressions that have I in them. And you can treat the imaginary number I just like you would a variable. So when I want to combine 3 plus 5I plus 2 plus 4I, I just combine like terms. Notice that there's a plus in between the parentheses. They're not right up against each other, so be careful you don't want to FOIL that. We're just going to combine like terms. So if I add 3 plus 2, that's 5, and then I can combine positive 5I and positive 4I and get positive 9I, and then that's as far as you can go with that. If we take the plus out and put the parentheses right up against each other, then we're going to multiply the contents of the parentheses together. And I like to use the FOIL method, which is first, outer, inner, and last, but there are other ways to multiply a binomial times a binomial, 2 terms times 2 terms. So if I multiply first, that would be 3 times 2, which is 6. The outer is 3 times 4I, which would be positive 12I. The inner, 5I and 2, would be positive 10I. And last, 5I times 4I. The 5 times 4 is 20, and then I times I is I squared. So we said just a minute ago, I squared is the same thing as -1. So anytime we have an I squared, we'll replace it with -1, and that will be multiplied by the 20. So -1 times 20 is -20. So I squareds turn into -1s. Now I can combine like terms. 6 minus 20 would be -14. And positive 12I plus 10I, positive 22I. When a fraction has an imaginary number, or a radical for that matter, in the denominator, it's not in proper form. To get it in proper form, we must multiply the top and the bottom of the fraction by the conjugate of the denominator. This is the denominator with only the middle sign changed. For example, if I have 6 plus 4I, the conjugate is 6 minus 4I. Or if I have 5 minus 7I, the conjugate is 5 plus 7I. The middle sign changes, and that's what makes them conjugates. Everything else stays the same. So to simplify this fraction that has an imaginary number in the denominator, I need to multiply the top and bottom by the conjugate. So I change just the middle sign to minus 3i, top and bottom. On the top, I need to distribute the 5. So that's going to be 10 minus 6i. On the bottom, I can FOIL. So when I FOIL that, first 2 times 2 is 4. Outer, 2 times negative 3i is negative 6i. Inner, positive 3i times 2 is positive 6i. And last, positive 3i times negative 3i. So positive 3 times negative 3 is negative 9. And then I times I is I squared. The middle two terms, negative 6i and positive 6i, cancel out. This always happens with conjugates. So when you're multiplying conjugates and you're using the FOIL method, you can skip the outside and inside, the outer and the inner, because those two things always cancel. So you can do just first and last and take a little shortcut. Also on the bottom, we see that we have an I squared. I squareds always turn into negative 1s. So the bottom is going to become 4 plus 9 when you multiply the negative 9 times the negative 1. 4 plus 9 gives me a 13 on the bottom. On the top, there's nothing I can do with that. And I see I've made a mistake there. It shouldn't be 6i, it should be 15i. 5 times 3 is 15. There we go. So the top should be 10 minus 15i. Once you've simplified that down as far as you can, you always check to see if you can reduce. If all of your numbers will divide by something, reduce it down. And it has to be all 3. It can't just be 2 of the numbers. So 10, 15, 13 don't have anything in common, so that's as simple as that one goes. The next one is 4 minus 3i over 1 minus 2i. So I need to multiply the top and bottom by the conjugate, which would be 1 plus 2i. Just change the middle sign. On the top, I have a binomial times a binomial. Those, I can't cancel out the outer and inner terms. Those are not conjugates. I have to FOIL that out. So the top is going to become 4 times 1 is 4. The outer, 4 times 2i is positive 8i. The inner, negative 3 times 1 would be negative 3i. And for the last, negative 3 times 2 is negative 6. And I times I is I squared. On the bottom, because I have conjugates, I can multiply just first and last and do the shortcut. So first would be 1 times 1 is 1. Last would be negative 2i times positive 2i. So negative 2 times positive 2 is negative 4, and the I times I is I squared. Everywhere I see an I squared, I need to replace it with negative 1. So on top, my minus 6 times minus 1 turns into a plus 6 to be combined with the 4 is 10. And then in the middle, 8i minus 3i is positive 5i. On the bottom, the negative 4 times the negative 1 gives us plus 4, so 1 plus 4 is 5. Now again, look and see if there's something you can divide all 3 numbers by, and you can this time. Everything divides by 5. Has to be all 3 or none. So dividing everything by 5 on the top, 10 divided by 5 is 2, plus 5 divided by 5 is just 1i, all over 1, which you don't have to write. For this problem, the first thing we would want to do is convert the square roots. We don't want to have those negatives under the square root. So to take the square root of a negative number, just take the square root like you would regularly. The square root of 25 is 5. So 4 times 5, and then because of the negative, it's 5i. Plus 2 times the square root of 9 is 3, and because of the negative, it's 3i. And then following order of operations, we always do multiply before we do add. 4 times 5 is 20i plus 6i, which is 26i.